Hi everyone, welcome to the channel. Today we'll be looking at this problem called minimum area rectangle. And this problem is a Google interview question. And so before I begin, I'd like to point a few things out. One is that for Google interviews, for the earlier stages, they may have you have a Word document or a Google document. And on the Google document, you'll be shown the problem description and be asked to code out the solution. So I bring this up because maybe you follow my videos and you've been seeing me do it on LeetCode, and it has all this highlighting for the code. And so maybe if you're practicing for the Google interview, it'd be nice, just a heads up, that maybe you want to practice with the Google document. Get yourself comfortable without seeing the highlighting and the indentations and being able to do that. Second thing is for the on-site at Google, those will be whiteboarding questions. And so what I made is I have a website, and it's in the link is in the description below. And on the website, I'll post solutions to how to do the whiteboarding problems. And so it will involve me taking snapshots of the whiteboard and explaining my thought process. And yeah, because I think these videos are nice if you get this as an online coding interview question, or if they give you an IDE, or if it's online. But then for whiteboarding, there's another element. So I just want to make sure you guys get the thorough practice and that all holes are covered. And with that being said, if you like the content, please like the video and subscribe so you can see and get the latest updates. Also, for those that commented, thank you so much. I look forward to all your comments and feedback. I try to answer all the questions and take those into account for the videos. And so, yeah, keep those coming. Without further ado, let's begin. And so for this minimum area rectangle problem, we're given a set of points in the xy plane, and we want to determine the minimum area of a rectangle formed from these points with sides parallel to x and y axes. If there is not any rectangle, then we return 0. See here's an example. Area 4, so we have 1, 1. See 1, 1's here. 1, 3. Also have 3, 1. 3, 1 for the first example, and then 2, 2, somewhere in the middle. We have 3, 3. So see the rectangle is on the outer side, and the difference of these two is 2. Difference of these two is 2, so the area is 4, and so that's how that solution is attained. And so for this problem, I'd say one cautionary note is usually for these problems, it's really good to write out a long input. The longer your input, the better. That way you can catch different corner cases and edge cases. I would say for this problem, it's easy to get drowned by a long example, just because you need 4 points to make a rectangle. So if your example has you randomly come up with points and you don't have 4 points that make a rectangle, then it can make this problem a little bit challenging. But in general, yes, writing a long input is better than short input. I'd say for this problem, maybe it's an exception. Let me know in the comments below how you feel about that strategy. So we try this. We see that here's 4 points that make a rectangle. And so a possible solution is to go through all pairs of points. And so if we go through all pairs of points, it would be O of n squared. The reason why I want to do pairs of points is, let's say these are the start points, this is the pair. Once we have this pair, then we can scan vertically. So scan all the points on the top and scan all the points on the bottom to see if there's another pair that can make a rectangle. And so the scanning part will take O of n. And now let's consider, and so overall this will be O of n cubed. So let's consider if we can do slightly better. And so to do slightly better, it looks like the pairs must be done because well, once you get the pair of points, we can narrow down what the other 2 points have to be. So if we have 2 points on rectangle, we can find other 2 points. So an example is if we stars are the points that we're looking at. So let's say we have these 2 points. If we have these 2 points, we know exactly what the other 2 points are. And so this I'll call points on the diagonal. Now, one other thing might need your help in the comments below is what is an anti-diagonal? And I think anti-diagonal is from 1-3 to 3-1, but you guys let me know in the comments below. And yeah, so we take a look at the diagonal. We have the 1-1 and 3-3, and we said that if we have 2 points on a rectangle, we can find the other 2 points. And so what we can do is we see, let's label this x1, y1 for the coordinates, and then this one x2, y2. So we see that if that's the case, we know the other 2 points. We have 1, 3, 1, 3, and 3, 1. And so if we use the notation, we see that it is y1, x2, and y2, x1. So, well, let's see if we change the numbers. It can help us discern because both x2 and y2 are 3. So maybe we might have some doubts on whether or not that will work. So let's say this is 1, 2. And this is 3, 2. We could, well, the column has to be the same. So let's say it's 4, 2. Wait, yeah, 4, 2. So it has to be a 2. And this is 4. Well, we change this to a 1. Wait, hold on. So the column is 2. Let's change this to 1, 2, 4, 2. And then we want the column to be different. So let's make the column 3. The row is still 1. This would be 3, and then the row is row 4. Alright, hold on. Now, is this a rectangle? Difference of these 2 is 1. Difference of these 2 is 3. Alright, so if we follow the same method, then the stars we chose 1, 2, and 4, 3. And then we see the diagonal or the anti-diagonal points 4, 2, and 1, 3. Let's see if the formula holds true. So y1 is 4. It is not. X2 is 4. x2 is 4. See, the first example was that x2 is 4, and then y1 is 2, and 1 is x1, y2. Okay, so it looks like this was for the previous example, and this is the current example, and it looks like the formula for this one works. So now if we see that the previous example, it's good that we wrote this out, so we saw that the previous example, this formula is incorrect. And we know that the previous example will also be correct by using this second formula, because the previous example, there are two coordinates that equaled each other, and so switching it would not make a difference in that example, but switching it in the current formula would. So choosing the current one is the correct example, and we can check without looking at the example. We can see that here is our x1, and so the anti-diagonal, the second point, should also have x1. That's what we have here. And then the y1, we see it's up here, so it should be for the first of the anti-diagonal, that's here. And then for the x2, or here's x2, it is the first x coordinate of the first anti-diagonal, and that's what we have there. And then y3, which is 3, is the second anti-diagonal, or not y3, but y2, and we see it's right there. So two ways to check. One is with the number. Second way is to look at the rectangle, and then look at the anti-diagonal, and then look at the diagonal. And so this is now correct. And what this method shows is that when we have two pairs, oh, well, I already wrote it down, which is this part. When we have 2 points on a rectangle, we can find the other 2 points. And so this scanning, we now change it to constant time, because we can find the 2 points. And so this now becomes O of n squared. So now we could go a little bit deeper, and we can consider cases and trying to write out the main idea. And so one thing is, if we have less than 4 points, we return 0, because there isn't any rectangle. So if less than 4 points, return 0. Next is we want to store the length, right? So store length of points array. And then the other thing is we want to cache the minimum area. And then for here, since we have an array of points, and we want to check a pair, we want to make sure that duplicate points are not checked. And so we need some data structure to store points and eliminate duplicates. Also, we want constant check for given 2 points, constant check to find other 2 points that make rectangle. Let's separate out these things. We know for coding it's a little bit easier to know the parts. And yeah, so here we go. All right, so once we do that, then if we have valid rectangle, then calculate area. And because we're iterating through the pairs of points, it's possible that we might iterate the same point. And in that case, area is 0 when same points make a pair. So if area is not 0, then check if it is smaller than current minimum area. Update minimum area. And because we have that data structure, well, if we want constant check, we know it's a hash map. What we can do is insert key as x1 and y1, basically x and y coordinate, and effectively this makes it a hash set, since the keys will be the same and we're writing the same value. And then we see that it's possible for no rectangles to be formed, even though we have more than 4 points. So that's why we need to check if no rectangle is formed. Then we will return 0 because it's not possible to make any rectangle, else we output the minimum area. Okay, so that looks like we're covering the cases and covering the points. So let's remove this so we can begin coding. Length, we'll call it length, and then if it's less than 4 points, if length less than 4, we'll return 0. I want to cache the minimum area. Minimum area equals, we'll start with infinity. Now we need a data set or a data structure for hash set, and we said we wanted to use a map, and because of the ways we insert the keys, it will mean that we have a hash set and not a hash map. So iterate points for all pairs. And so to get the pairs, we'll do for I points, well, x1, y1 in points, x2, y2 in hash set. Because in our hash set, we don't have the duplicate points, and so it'll be slight optimization. All right, so now we check if we have a valid rectangle. So if, and we have our formula from before. Oh, I see. I deleted the formula. Funny story. All right, so no matter, we could, actually it wouldn't be too hard to, let me do this. And then we'll go back. Are we allowed to go back? Yes. Oh my. All right, here's the formula. We want to keep that. And there we go. All right, so here's the formula. That's the thing we want to check. So we want to check if x2, y1 in hash set and x1, y2 in hash set. So that's true. We check if, well, first do area. Area equals absolute y2 minus y1 multiplied by absolute x2 minus x1. And if the area is not 0, then we update the minimum area. So if area and area less than minimum area. Then we update the minimum area. All right, so now we will check if rectangles formed. And we know that we started with minimum area equals infinity. So if we execute the following nested for loop and there's no, the minimum area is still infinity, then we know that no rectangle is found. So we can do inline if statement and return the minimum area if minimum area not equal to float infinite. Else 0, because if it is equal to infinite, then yeah, we know that no rectangle is found. So we talked about the runtime before. It's O of n squared, and the amount of space is O of n, because worst case is all the points are unique and we have to store it in our hash set. So now let's take a look at an example. We could take a look at example 2 just to make sure it's working. So first thing is checks the length. And we see the length is 1, 2, 3, 4, 5, 6, and then minimum area is infinity. Hash set's empty, so we iterate through the points. So now we have 1, 1. And then our hash set is empty. So the first time we iterate through the hash set, nothing would happen. And then we move on to the next point. Ah, I see. One mistake I made is I never inserted anything into the hash set. So hash set x1, y1 equals x1, y1. That way, once we get the key, which is the tuple, x1, y1, we can get the coordinates, which would be the value x1, y1. So after the first one, first iteration of 1, 1, basically nothing happens because the hash set is empty. Then our hash set has 1, 1. Now we're on 1, 3. Then our hash set has 1, 1. And then after this, we check the x2, y1. And so x2 is 1. So we check 1, 3. And it is in the hash set. Well, this is x1, y1. So this is, yeah, x2, which is 1, y1, which is 3. So we check 1, 3, and that is in hash set. And then we check if x1, which is 1, y2, 1, 1 is in hash set, and it is. So we calculate the area. But because the area is 0, we do not update the minimum area. And that looks like what we want it to do. And then we add 1, 3 into the hash set. Now 1, 3 is there. Then we check 3, 1. And so for 3, 1, x2, which is 1, y1, oh, well, we do this one first. x2 is 1, y1 is 3. So we check 1, 3 in the hash set, and it is. And then we check 1, 1. 1, 1 is also in the hash set. And then we calculate the area for this. So y2 minus y1, I see, it also gives 0. So then we see 1, 3. And so x2 is 1, y1 is 1, and the x1 is 3, y2 is 3. So yeah, now we calculate the area. And so x2 minus x1, which is 1 minus 3, absolute is 2, and then y2 and y1, y2 is 3, and y1 is 1. So yeah, we get the area of, well, got an area of 4. Oh, okay, we do get an area of 4. It's because later we'll get an area of 2, and that'll be smaller. Okay, well, for this part, it looks like this section is correct, so we don't need to continue checking the rest of the points. We can, based on our check right here, we know that this is doing what we expect it to do, and then we check the minimum area. So if the minimum area at this point is float infinite, then we know that we were not able to find an area that's smaller than minimum area and a non-zero area, because if we have area equals 0, this would not be true. All right, let's submit, and let's run the code, see if it works. Looks legit, looks legit. All right, let's submit. All right, awesome. Looks like it's submit and looks fine, dandy. All right, so thank you guys for your time. I hope you guys learned something and had as much fun as I did. Again, if you like to support this channel, please subscribe and like this video and provide feedback of things that you want or you find are interesting, really, because ultimately supporting me in these ways, it's so that I can bring you guys more relevant and good content. And really, this channel is about us all learning together. So in the end, it's all about us. And yeah, I really appreciate all the support you guys have given me so far. And yeah, I look forward to seeing you guys in the next one.